Hello everyone. So in this topic we talk about dipole in external electric field. So let us suppose a dipole having dipole moment P is kept in uniform external field whose intensity is given by E such that the dipole moment and external electric field E make angle theta. Here dipole moment is P and the intensity of uniform external electric field is E and theta is the angle between dipole moment and electric field E. So in the given figure, here the pink line is indicate external electric field. External electric field. And this is the dipole, negative charge of a dipole, and this is the positive charge of a dipole, and distance between them is 2a. Now we need to find the direction of a dipole moment. As we know that the direction of the dipole moment is from negative to positive charge, so direction is this. So this is the direction of dipole moment. Now as we know that whenever any charge is placed in the electric field, then charge is act if charge is acting force on it. Like we have seen that electric field is force upon test charge. Here force is equal to electric field into Q. So the positive charge when placed in external electric field, it acts a force in the same direction as the electric field. When negative charge is placed in external electric field, it will act in the opposite direction as external electric field. Direction is same for positive charge and electric field. Have the same direction. And direction is different, or we can say it opposite of negative charge and electric field. So by the given figure, we have seen that on the dipole we have two forces acting in opposite direction. So we can say that the overall zero force acting on the dipole. Now here theta is the angle between electric field and the dipole moment P. Since from the given figure we have already seen that there is a net force is 0 in the dipole. Apart from this, the line of action of the two forces is not same. the line of action of the two forces is not same. So the dipole is experience a torque tau. So in this case, we talk about what is the line of action. So from the given figure, this is the line of action. This point is indicate the line of action. If line of action is same, then in this case no torque will act. No torque will act. If line of action is different, then couple or torque will act, which helps dipole to rotate. Now further we can see that see the expression of a torque. So as we know that torque is equal to force into perpendicular distance. Here the force is given F is equal to QE, and we need to find out the perpendicular distance. So in the given figure, Bn is a perpendicular distance. Bn is the perpendicular distance. So by using some trigonometric law, we will find Bn. So as we know that sin theta is equal to perpendicular upon hypotenuse. Here perpendicular is Bn and hypotenuse is 2a is equal to sin theta. So we conclude that force is equal to QE and distance Bn. So we can write QE into 2a sin theta. So this is the torque acting on a dipole in external electric field. So further we can write torque tau is equal to uh, 2qa e sin theta. Since we know that dipole moment P is equal to the magnitude of a charge and distance between the dipole, distance between the two charges of a dipole. So that so P can be written as Q into 2a. So we can write that P E sin theta. So by the law of vector, we know that A cross B is equal to AB sin theta. So we can conclude that it is written like P cross E. So this is the net torque acting on a dipole in external electric field. So from the given expression, we have obtained the magnitude of a dipole. Now we need to find out the direction of a given torque. So the direction of a torque is in the plane, so we can write that direction of torque is in the plane containing P and external electric field E. Now, since we have obtained the expression for a net torque in the dipole, so it is tau is equal to P cross E is equal to P into E sine theta, where sine theta is a angle between P and E. Here sine theta angle between P and E. So the torque will be 0 when the angle between P and E is 0 or 180 degree. So in other words, we can say that if P and E are parallel to each other, if P and E are parallel to each other, then in this case the torque will be 0, and P and E are anti-parallel to each other, then again torque will be 0. So when P and E, they both are parallel, so angle between them is 0. So tau will be 0, and when P is this direction and E is in this direction, so in this case also the torque will be 0. That because sine 0 is 0 and sine 180 degree is 0. When a dipole is in parallel, then it is called stable equilibrium. When dipole is anti-parallel, then it is called unstable equilibrium. It means that if the angle between dipole moment and external electric field is 180 degree, then it is called unstable equilibrium. And last we have seen that torque will be maximum when field and dipole moment are perpendicular to each other. It's like field is here in this direction, and our dipole moment is in this direction. So angle between them is 90 degree. So sine 90 will be 1. So in this case the torque will be maximum. So we can summarize that tau will be minimum minimum in two cases: when theta is equal to 0 degree, when theta is equal to 180 degree. When theta will be 0, then it is called parallel. It is called parallel because P and E in the same direction. P and E in same direction. So it is called stable equilibrium. When theta is equal to 180 degree, it is called anti-parallel. P and E in different direction, and it is called unstable equilibrium. and tau will be maximum, its value is equal to P into E. It only occur when theta is equal to 90 degree. This indicate that angle between P and E is 90 degree. So the the magnitude of a torque is entirely depend on the placement of a dipole in external electric field. So further we can conclude that the direction of the placement of dipole in external electric field will determine the magnitude of torque tau. So that's all in this topic.